इन दिस वीडियो हम डिस्कस करने वाले हैं हमारे जुलाई चैलेंज का लास्ट टॉपिक. ओके, और वी कैन से लास्ट लीड कोड प्रॉब्लम ऑफ द डे. So basically our problem is filling bookcase shelves. So let's read the problem statement one time. You have been given an array of books. The books of y equals to what? Thickness and height. Basically you have, this is a book. For example, this is what the thickness of a book and this is basically the height. The height and the thickness of a book are given, and you are also given an integer shelf width. We want to place the books in order onto bookcase shelves that have a total width shelf width. Okay, basically this is a bookshelf. Okay, and shelf we have been given a shelf width. Okay, shelf width we have been given. So basically in this shelf we have to put the allocate the books properly. So basically we can repeat this process until there are no more books are left to place. Means we have to place the books, and we have to go in the numeric order, means in the order of the array from 0 1 2 3, from the indexing. Means we for example uh, this one, let's suppose this example. Basically in this example this is 1 1 we have been given, then 2 3, then again 2 3. In this example we can't take this pair of these books, means we can't jump from 0th index to another index. We have to go line wise, means from 0 1 2 3 4. In this way you have to run. Okay, so basically now let's try to understand it with the help of an example. At last we have to return the possible minimum possible height that the total bookshelf can be. Means after placing the shelves in the manner, means after placing the books in the order, we have to return the minimum possible height. So basically how we can solve this problem? We can solve this problem by bottom up dynamic programming approach, bottom up DP approach, or we can say dynamic programming approach. Okay, so this approach we are going to use. Basically why not greedy approach? Why not greedy? Okay, why not we are using the greedy approach? Let's see. Greedy means, in English, what greedy means? Greedy means the we want the maximum. Okay, means we want anything, means going in the order like anything we can do. Okay, so this is basically the greedy. So now let's try to solve it with the help of greedy approach. Then we will solve it in the original manner according to the problem statement, according to the dynamic programming approach. Okay, so now let's try to begin. Basically we have been given an array of books. The the zeroth element is what? The zeroth element is the width, and the first element is the height over here. Okay, the zeroth element is the width and the first element is the height we have been given. So basically let's try to solve it by greedy approach. 1 1 we have been given a book of width 1 and height 1. Okay, we have placed it. Then our book is of width 2 and height 3. Okay, then comes a book with width 2 and height 3. Okay, we have got the width 2 and height 3, but shelf width is given what? Shelf width is 4. Our shelf width is 4. So basically over here, basically we have been done with 3, and we are left with only one width. But as you are able to see in the example, as you are able to see in the example, this we have been completed with this 2. But the third one, the third book is the dimension of the book is what? 2 comma 3, means it's with the next book is dimension is 2. So basically the tooth width cannot fit in the place of this one width. Okay, it cannot fit in the place of one width. So this can't be possible. So we have to put the next book in the next shelf. As I have told you, as you remember, that we have to go in the means increasing manner, means line wise we have to go. Okay, so basically our next one is another 2 comma 3. Okay, width is 2 and height is 3. Keep in mind the height of this is what? 3 over here. The height is 3 over here. Then comes what? 1 1. the book with 1 1. So basically another book is what, 1 1. Okay, so as we are able to see, let me erase it one time. Yes, as you are able to see that the we have completed with all the weights over here. The weight is what, 4 over here. 2 plus 1 plus 1 means 4. We have completed with all weights. And height obtained is what here, 3 over here. Okay, the actual first 3, then the next 3. Then again move forward. We are completed with we are left with only 2 books now. Okay, the next 2 books with the dimension 1 1 means its width is 1 and height is 1. Another book, its width is 1 and height is 1 2. The height is given is 2. Basically here our width, total width is what, 2 over here, means it comes in the shelf width range of the shelf width. Okay, it comes in the range, so no tension. Basically now we have got our height as 3 plus 3 plus 2. 3 plus 3 plus 2 equals to what, 8 over here. This height we have got by the greedy approach. By the greedy approach we have got this height over here. So basically we know we can now we are going to solve this by bottom up dynamic programming approach. Bottom up dynamic approach. So now let's start. First of all, place the book with dimension 1 comma 1 means width is 1 and height is 1. Basically let's make this as 4. The shelf width equals to what, 4 over here. Then place another means then place another book over here with dimension 2 with width 2 and height 3. Another book also with 2 and height 3, means now we cannot place any other book here. Okay, we cannot put any other book over here, as the width, total width here is what, now become 4. We cannot move forward, so we have to move to next shelf over here. Okay, so our next book is what, with 1 1. Then another book with 1 1. Then also another book with 1 1. And then another book with 1 2 with 1 and height 2. Basically as you are able to see, the total width is what, 4 over here, means we have completed. Now see the height. The height of this is 1. The height of this is what, 3 over here. Wait a minute. The height of this is what, 3 over here, and the height of this is 2. Okay, so basically we have got total height as what, total height as 6 over here, means 6 is the minimum height we can obtain. So this is the advantage of bottom up dynamic programming approach. Okay, so means in this way we cannot solve it by greedy approach. We cannot solve it by greedy approach. So our dynamic programming approach is better one. Okay, bottom up dynamic approach. So basically how you can solve this problem, basically how you will be able to solve the problem, you have to use an array called dp over here. Okay, you have to use an array dp. Basically means it will contain the minimum height required to place the first I books. Okay, it will contain the minimum height to place the first I books. Basically let's suppose this example. Let me add some text over here, the example. Let me copy it. Let me give some spaces, wait for a minute. Yes, this is our basic example. Okay, so we will create an array called dp over here. Okay, we will create an array called dp over here, the dp array. Okay, so basically means we'll create a array or a list called dp, where each dp of I represent the minimum height needed to arrange the first I books, this first I books. Okay, basically we'll initialize our dp of 0 to means 0, means no book requires 0 height. So first of all let's begin the approach, begin with the approach over here. Okay, so now let's begin. First of all, we will initialize our dp toward infinity, 0 to infinity. Okay, this is our dp. Okay, basically this is our dp over here. Let's suppose this example only. Let's suppose this example over here. Okay, this is the basic example we are going to talk about. Okay, so basically let's see, we will initialize our dp to first element of our dp to 0. Why? Because no book requires 0 height. Okay, no book requires 0 height, and in all cases, first let's see that total, what, how many books we have. Total of books we have 1 2 3 4 5 6 7, means we will initialize the infinity with n plus 1 times, infinity till n plus 1 times, means n plus 1 times. Our n is what over here? N is 7. Okay, till n plus 1 time, this will be our dp over. Okay, so first of all we will process for each book. We will process means iterate through each book, means from the position I from 1 to n, where n is what? Total number of books. So our inner loop for shelf placement will another take another loop for our shelf placement. Okay, so first of all begin, we have created a dp over here. Then for I in range n. Okay, friends, let me solve it by coding approach. Okay, so it will be more easier for you to understand. Let me delete it first of all. Yes, first of all, as you are able to see that n is what? Our length of the array called books, means total of, according to this example, we have total of what? 7 books. Okay, total of 7 books over here, means n is what? 7. Okay, as basically you know. Then we have created a array called dp, means, and put infinity in all position, means taking the maximum, means we have set all other values in dp to infinity, so that we represent this states haven't been computed yet, means it will represent that the states haven't been computed yet. And we have initialized our zeroth dp, this zeroth dp to 0, so that the no books require 0 height. Okay, all books have somewhat height. Okay, but there is no other book which have 0 height. That's why. So now next step is what? We will iterate, we will do the iteration. Okay, so basically this one. Yes, for I in range, for I in range 1 to n. Why not 0 to n? 0 is not, because we are not taking 0 because we don't need 0 height. Okay, that's why 1 to n plus 1, sorry, 1 to n plus 1. Okay, that's clear. So we will initialize our top book and bottom book. Okay, we'll do the initialization process, means top width or maximum height, we can say top width or maximum height. Okay, we will initialize it to what? We will initialize it to 0. So basically total width equals to what? Total width equals to 0 over here. And basically our maximum height equals to what? Maximum height equals to 0 over here. So we have initialized. Then we will run another for loop, we will iterate through another for loop. I will explain each and every approach. Basically we will now iterate through another for loop. Why we are using this? Means why we are running inner loop for shelf placement. Let me first write the code first. For j in range, for j in range what? J in range I to 0. Okay, means we are going in reverse order. From I to 0 we are going, and doing -1 means decrementing by one by one. Okay, so basically why we are using this inner loop? For each means we are using this for shelf placement. For each book position I will explore the placing of books from position J to I on the current shelf, so that we will compute the total width and maximum height of the books from J to I. Okay, keep in mind from J to I for computing the maximum height of books. Okay, keep my words in mind. So we will do what? Increment our total width. I will do the dry run of the code also on the whiteboard, so stay tuned. Books of what? J minus 1. Total width of J minus 1 to 0 means the zeroth one. Okay, and then if our total width, if our total width is what? If it is greater than, if it is greater than the shelf width. Okay, if the total width is means the width of the book, if it is greater than the shelf width, then what we will do? Then we will break, simply break. Because why? Because we can't exceed the shelf limit. Okay, we can't exceed the shelf limit, so just break the loop and then initialize the maximum height. Maximum height is what? Maximum height is what? Maximum of maximum height, max height, we can say max height, or the books, the current books we are going through. J minus 1 and of 1. Okay, this is basically the zeroth index is what? The 0 1. This is the left side is what? Width, and the right side is height. So this is 0 and this is 1. Okay, that's why book of J minus 1 till 1. Okay, we are going from book of J minus 1 till 1 means updating the DP of I. Means if the total width of the books from J to I exceed the shelf width, we'll break out the loop because you can't fit more books on the shelf. Okay, that we have done. But the maximum height, we are updating the DP of I with minimum height required by considering the height of if the books from J to I are placed on the current shelf. Okay, so now we will initialize the minimum height over here. Now we will initialize our height. DP, update our DP of I, we can say we'll update our DP of I equals to what? Minimum of DP of I till DP of J minus 1, or the DP of J minus 1. Means we have updated the DP of I, means it will be the minimum of DP of I or the GP of J minus 1. But as you know, DP of I is what? Infinity. So that's why we are taking this. Wait a minute. Another one. What we will do? We will add the maximum height over here. Why I am adding the maximum height? Okay, why I am adding the maximum height? Because the height required by considering the height if the books from J to I are placed on the current shelf. Okay, that's why I am adding. Okay, and at last we will what? Return the result over a DP of n. DP of n we will result means after processing all the books, DP of n will contain the minimum height required to arrange all n books. That's why we are returning the DP of n. Return DP of n. Okay, so first of all, let's do the dry run of this code. Let's do the dry run of this code. Okay, we will get a clear idea of the question, means how to solve this question. Okay, we will get the clear idea of it. So basically, let's begin. Yes, so now basically we have been given the example this. this example we have been given. Let me rub it. Okay. Yes, so we have been on this example. So first of all, we have created a dp of 0 from infinity of all infinities. We have total n is equals to what? N equals to 7. So basically we have 7 infinities and the 0th element initialized to 0. Okay, we have done this. So first of all, we will iterate. Now we will iterate from 1 to n plus 1, the for loop. Whenever our I is equals to 1, our only book is what? 1 only. Our book 1, I equals to 1 means our book 1. So basically our total width equals to what? 1 over here, and max height equals to 1. Basically our dp of 1 will be what? Minimum of, it will be minimum of dp of 1 and dp of 0 plus 1, means dp of 0 plus max height, dp of 0 plus max height. Okay, as we have stated here, dp of I equals to minimum of dp of I plus dp of j minus 1 plus max height. Max height is what? 1 over here. So our dp of 1 means dp of I equals to what? 1 basically. So it will be minimum of infinity with 0 plus 1. So our dp of 1 will be what? 1 over here basically. So we'll move on to next iteration. Iteration number 2 means we have here book 1 and 2. We have here total book 1 and 2 basically. So with book 1, let me increase the font over here. Yes, we have of total book 1 and now 2 in iteration number 2. This is book 1 and 2 over here. Basically our total width is now 1 plus 2. Okay, which is equals to now 3, and maximum height is what? It will become max of 1 and 3. It will become max of book maximum height with books of j minus 1 till n. Okay, so it will be max height will be what? 3 over here. Now next move forward, our dp of 2, dp of I equals to what? 2 over here. It will be what? Minimum of dp of 2, minimum of dp of 2 with dp of j minus 1, means j minus 1 is what? Dp of 1 plus 3, dp of 1 plus 3 means it will be what? Minimum of infinite 1 plus 3, 1 plus 3 over here basically. So our answer will be what? Minimum 4. Dp of 2 will be updated to 4 now. So as we are decrementing over here from j means I to 0, we are going downwards. Okay, we are going downwards. So now our book will be reduced to book number 2. First we have book 1 and 2. We have first book 1 and 2. Now we have book 2 only. So now total width is equals to now 2. Okay, total width is now equals to 1 plus 2, which is equals to 3 over here. Okay, and maximum height, which is equals to what? Max of 1 and 3, max of 1 and 3, which is equals to what? 3 over here. Okay, so basically our dp, updating the dp of I, we are updating the dp of I over here. We have updated the max height. Now dp of I, which is equals to now 2. So minimum of dp of 2 and dp of 1 plus 3. Okay, j minus 1 plus maximum height over here. As you know, the means see the formula in the code. Okay, so basically it will be what? 4 over here. No, sorry, it will be 0 plus 3 infinity comma 0 plus 3, which is equals to 3 over here. So dp of 2 is what? 3 over here. Keep in mind, dp of 3 is dp of 2 is 3 over here. Okay, so now iteration number 3 came to iteration number 3 over here. So book, basically book 1 to 3, book 1 to 3, we have total width of what? Total width of 1 plus 2 plus 2, which is equals to 5. But 5 is what? 5 is greater than 4, which is the shelf width. 5 is greater than 4, so it exceeds the shelf width, so we will break over here. Again move forward, book 2 to 3, 1 to 3 we have done, then 2 to 3. Total width is what? Total width is 2 plus 2, which is equals to 4. 2 plus means 4 is in the means in the shelf width. So okay, we will continue with it, and our max height is what? 3. Okay, so now our dp of 3 will be minimum of dp of 3 plus what? Plus dp of 2, dp of 2, minimum of sorry, it will not be plus, minimum of dp of 3 and dp of 2 plus dp of 2 plus 3, which is the maximum height over here. So it will be basically what? It will be basically 4. Our dp of 3 will be 4. Now book 3, our total width is what? 2, and our maximum height is what? 3 over here. Our maximum height is 3. So basically now our dp of 3 will be minimum of dp of 3 with dp of let me put it here, it will be more easier for you to understand. dp of 3 with dp of 3 with what? dp of 3 with dp of 0 plus 3. Okay, dp of 0 plus 3, so it will be minimum of 4 comma 0 plus 3, which is 3 over here. Okay, so we have dp of got dp of 3 equals to what? 3. So in this way all the iterations will run, and at last we will move on to iteration number 7. Okay, so we are at what? Iteration number 3 over here. Yes, so now iteration number 4. Okay, now we are at iteration number 4, means book 1 to 4. Okay, book 1 to 4, basically our total width is what? 1 plus 2 plus 2 plus 1, which is equals to 6, which exceeds the shelf width. Okay, so we will break over here. Then book 2 to 4 is what? Total width. Total width is what? 2 plus 1, 2 plus 2 plus 1, which is equals to 5. So it also exceeds the shelf limit, so we will again break. Then we will go to book 3 to 4. Book 3 to 4, we have total width of what? Total width equals to 2 plus 1, which is equals to 3. Okay, so it is in the shelf limit. So now maximum height is what? 3 over here. So okay, now we will update our dp of 4. dp of 4 is what? Minimum of dp of 4 comma dp of 2 plus 3, means infinity comma 3 plus 3, which is equals to what? 6 over here. Means minimum of infinity comma 6 is what? Minimum, it will be 6 only. Okay, so we have got our dp of 4, we have updated it. Now what? Book number 4. Now move on to book number 4. Our total width is what? 1 over here, and maximum height is also 1. So we'll update our dp of 4 now. So our dp of 4 will be what? Minimum of dp of 4 comma dp of 3 plus 1. Okay, so basically our dp of 4 is what? It will be minimum of 6 comma 3 plus 1. Okay, which is equals to what? 4 over here. 3 plus 1 is 4. Minimum of 6 comma 4 is what? 4 over here. So our DP of 4 will be 4. We have updated it. Now as we have completed in iteration 4 the book number 4. Book number 4 we have completed. So again we will move forward. At iteration number 5. Okay, at iteration number 5 over here. So basically at iteration number 5 we have book 1 to 5. So for book 1 to 5 total width is what? 1 plus 2 plus 2 plus 1 plus 1, which is equal to 7 as it exits the shelf width. So we have to break over here. Now our next book is what? 2 to 5. 2 to 5. So our total width is what? Total width is 2 plus 2 plus 1 plus 1. Okay, 2 plus 2 plus 1 plus 1 over here. So which is equals to 6. So as it exits the shelf width, so we will again break over here. Now book 3 to 5. Now see the total width. Total width is what? 2 plus 1 plus 1. 2 plus 1 plus 1, which is equals to 4. So as 4 is equals to what? 4 is equals to our shelf width. As you are able to see, 4 is equals to our shelf width. So we will move forward for updating our DP. So it will be iteration, as it is iteration number 5 over here. So our DP of 5 will be equals to minimum of DP of 5 with comma DP of 2 plus let me make DP of 2 plus 3. Okay, so it will be basically your DP of 5. DP of 5 is what? Infinity over here. Minimum of infinity comma 3 plus 3. So our answer will be 6 over here. Okay, we have DP of 5 as 6 over here. So again we will update in book number 5. Again we will update this in book 5. In book 5 our total width is what? Total width is 1 and maximum height is also 1 over here. So update DP of 5. Again it will be minimum of DP of 5 comma what? DP of 4 plus 1. DP of 4 plus 1. Okay, DP of 5 is where we have got over here 6. So minimum of 6 comma 4 plus 1, which is 5. So we have got DP of 5 again equals to 5 over here. We have updated it. So now let's move on to iteration number 6. Let's move on to iteration number 6 over here. Okay, so book 1 to 6, its total width will be 1 plus 2 plus 2 plus 1 plus 1 plus 1, which is equals to 8. So it exits the, so 8 is what? Greater than 4. 8 is greater than 4, so we will break over here. Okay, then book, let me make it more clear. Yes, so then wait a minute friends. This long explanation was for the, this was just a dry run for the dynamic programming approach. Okay, this was just a dry run. Okay, so basically our iteration 6 has been, I think, removed. No worries, we will make it again. So basically at iteration number 6, okay, means let me change the color. Means book 1 to 6, our total width is what? Our total width is 1 plus 2 plus 2 plus 1 plus 1 plus 1 over here, which is 8. So as 8 is greater than 4, so we will break over here. Then book 2 to 6, our total width is what? 2 plus 2 plus 1 plus 1 plus 1, which is equals to what? 7 over here. 7 is also greater than 4, means it is exceeding the shelf width. So we will again break over here and move forward. Then 3 to 6. Total width is what? 2 plus 1 plus 1 plus 1. It is equals to what? 5. As 5 is also greater than 4. So again break as it exceeds the shelf limit. Then we will move forward. Book number 4 to 6. Book number 4 to 6 means our total width is what? 1 plus 1 plus 1, which is 3. As 3 is less than or less than 4. Okay. So our total width is what? 3 over here. And maximum height. Maximum height is what? 1 over here. So basically this is iteration number 6. So we'll update dp of 6. dp of 6 will be what? dp of 6 will be minimum of, it will be minimum of dp of 6 with comma dp of 3 plus maximum height, basically your dp of 6 is what? Infinity. And our dp of 3 we have got as 3. Okay. And 3 plus 1, which is minimum is what? 4. So we have got our dp of 6 as 4. Okay. So now basically book number 6. Okay. Book number 6, basically our total width over here is what? 1 over here. Okay. Total width is 1 and maximum height is also what? 1 over here. So basically let's update our dp of 6. dp of 6 will be what? Minimum of dp of 6 comma dp of 5 plus maximum height is what? 1 over here. So minimum of dp of 6. dp of 6 is we have got what? dp of 6 we have got 4 comma 5 plus 1 over here. So our minimum is 4 over here. So our dp of 6 is what? 4 in this case. Okay. Then again move forward to iteration number 7. This is basically the last iteration. So please stay tuned and see the video carefully now. Total width is what? 1 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1, which is equals to what? 9 over here. As 9 is greater than 4, so we will break over here and move forward. Then book 2 to 7. Total width is what? 2 plus 2 plus 1 plus 1 plus 1, which is equals to what? 8. As 8 is greater than 4 over here, so we will, it is exiting the shelf width. So again move forward, break over here. Then 3 to 7. Total width is what? Total width is 2 plus 1 plus 1 plus 1 plus 1, which is equals to what? 6 over here. 6. As 6 is also greater than 4, so it exits the shelf width. So again move forward. Then book 4 to 7. Total width, checking 1 plus 1 plus 1 plus 1, it is equals to 4. As 4 is equals to 4. Okay. As it is less than, or it must be less than or equal to 4, so it is in the range over here. So we will iterate it for dp number 7. The last iteration means dp of I equals to 7. Our minimum of dp of 7 over here comma dp of 4 plus maximum height. Maximum height is what? 2 over here. I forgot to put the maximum height. Our maximum height here is what? 2. Okay. Our maximum height is 2 over here. Okay. So maximum height of 2. So basically dp of 7 and comma dp of 4 plus 2. Okay. So minimum of basically infinity comma 4 plus 2. dp of 4 we have got 4 over here. So basically our minimum will be what? 4 plus 2 equals to 6 over here. So again move, we have updated our dp number 7. So book number 7, this is the basically last book. Book number 7, which has total width equals to what? 1 and maximum height equals to what? 2. Basically dp of 7 equals to what? Minimum of dp of 7 comma dp of 6 plus maximum height is what? 2 over here. So we have got 2. Minimum of, we have got dp of 7 is what? 6 over here. Maybe dp of 7 as 6. So 6 plus 4 plus 2. Basically minimum of 6 comma 6 is what? Minimum of 6 comma 6 is 6 only. So as we have reached the last iteration, means dp of 7 is what? 6. This is basically the last iteration. So we have now returned the dp of n. dp of n is what? Lastly 7. So which is dp of 7 is equals to what? 6. So basically 6 is our answer over here. Okay, we have got our answers as 6. So this was basically the dry run. This was basically the dry run for the given code. Okay, I will share the GitHub link for the dry run, so don't panic over here. Now let's try to submit the code. I think you must have understood the code over here. Yeah, it's giving some runtime error. What it's saying? Type not valid for the rest. Okay, basically it's giving some runtime error over here, so it's okay, we can clarify it. Basically it's giving error for infinity. Okay, it's giving error for basically what? Infinity over here. Okay, float infinity into n plus 1 dp of 0 equals to 0, dp of I equals to 1. Basically I have got the error over here. There was a simple thing, just I have taken the return statement outside the for loop, so no worries. Now let's try to run the code. Yeah, it's giving the expected output over here. Now let's try to submit it. Basically our code is being accepted over here, so we have got our code accepted. So thank you friends, see you in the next video.